Story graphs. A story graph is a rough sketch. Sometimes it has a scale, sometimes it doesn't, and it compares one variable. It's usually distance. And height is a special type of distance. So those graphs we just looked at, we're measuring distance up, height, right, to time. Now, it's not always distance or height, and I guess in a way it doesn't always have to be time, but the ones we look at are basically always time, and they're the most interesting ones. Usually it's telling a story over time, okay? And as we talked about, if I'm going to do a very rough one over here. So this one has no scale again. And it goes up, it goes over, it goes down. This is not necessarily walking up a hill. This is what some people will think. They walk up a hill, they stand at the top of the hill, and then they walk down the hill. It doesn't mean that. If this is distance from my house, this means I walked away from my house and then I walked back to my house. It doesn't mean I walked uphill, always. Okay, this would be time. So as time changes, and this is where a story graph has a bunch of different parts to it. It's not one straight line like all the other things we've been exploring. This one has 3 straight lines on it that are connected. Usually they're connected like that. Okay? And when we think of story graphs, we think of the following things, and these are the kinds of things that you could talk about if you were describing one or writing one or making a graph of one. These are the things that you would look for. You would look for speed, and speed is a rate, like the rate of or the change. Okay, and a steeper line means faster for us. And the speed has 2 parts to it. It's how far you went, but in how much time. I could go really slowly for a really long time and go further than somebody who went fast for a short time, right? We all know the story of the tortoise and the hare. So you could be fast, but if you're only fast for a minute, you're not going to go as far as a marathon runner running for 2 hours, right? So direction is usually, are we going away or towards? And it's going to be something like the house, school, the store, the ground, if it's height. You don't want to be going towards the ground too quickly. And so again, in my little graph up here, at one point, as I said, I'm moving away from the house. At one point, I'm moving towards the house. I don't care if it's east, west, north, south, left, right, diagonal. Like that part we're not as usually worried about. We don't know. Okay? We're just thinking, is the distance from your house getting bigger or getting smaller? And right here is 0 distance to my house. And right here is some distance to my house. Does that make sense? So see how you got to think about it in a different way. It's not a picture. It's a graph. The time spent and the distance covered. So time is usually across the bottom. And distance is usually up the side. Pretty much always. And sometimes you have a scale, sometimes you don't. So if you're not given a scale, you might be able to say faster and slower based on the steepness of the line. But if you have a scale, you might be able to say they went 100 meters. So we're going to look at both kinds of questions when you're given a scale, when you're not given a scale. Everybody got this okay? So there's your things to think about. Your speed, how steep is the line? That's a really important idea, basically. Direction, are you moving away from your house or towards your house? And the time spent in the distance covered, you might be looking at a scale or you might not. Okay, so we're going to mark up this graph and talk about some things. Distance from school, that means this is school. Because when it's 0 distance from school, I'm at school. If my distance from school is 0, I'm at school. This has a grid on it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What is that? 11 seconds, 11 minutes, 11 hours? We don't know. So that's not important for this question. What's happening in this first section here? How would you describe it? This is the kind of thing that we're going to do. We don't know specifics, but what could you say? Yeah, you're walking. Good. What else? Where are you walking? Okay. Good. See, these are all things that could be happening, right? And you might get to pick the story. Going for lunch or going home after school or something like that. Ethan? But what we know for sure is they're going away from the school. So I'm going to write that. And that's what a lot of you meant when you said going somewhere. They started at school, now they're going somewhere. They're going away from school. What's happening here? So we might call this one like section A. We might call this one section B. Sometimes we give them letters, sometimes we don't. Marley? Say that again. They got to a place and they're spending time there. What exactly do you mean by that? Or what exactly does Jamarly mean by that? They stayed there. What do we mean by that? Good, I like it. They stopped, or they're not moving. They've stopped standing still. Their distance is not changing. What if this distance was 500 meters? For this whole part, it's 500 meters. It doesn't change. So this is not moving. What's another part of the graph where they're not moving? Savannah? So not here, but the next section. So another one where we're not moving. Good. Up here. What's happening in the third section of the graph here? Okay.
Maybe they were late for school and had to run fast.
Why do you say running?
Because that distance is like longer over time.
Yeah.
And shorter.
Okay, so take a look. This is really, really important. Actually, I'm going to do it here. Okay. This distance of 1, 2, 3, 4 squares, let's say at lunchtime they are going to Dairy Queen, okay? So they, in this amount of time, however many minutes or hours or whatever that is, they cover this distance. They cover the same distance in half the time, a shorter time. So they're moving faster. And remember that idea of steepness has to do with being faster or slower. So maybe they were late and they were running back to school. Also, we know they're going back to school because they go back to where school is 0. Because this said distance from school, this is back to school. Okay, so what we're going to say here is faster. In fact, I'm going to do that in a different color. I know you probably can't, but... And this is slower because it's not as steep. So I'm looking at different parts of the graph and talking about whether it's steeper than other parts of the graph. If this was a question on EQAO or a test, you would be required to say, that section is faster than that section. That's what they want you to notice. That it's steeper, so that means faster. So somewhere in your answer, you would say they're going faster here than they were there. Okay? What's going on here? It looks to me like they're going fast again, don't you think? That looks quite steep. So I'm going to say this part's faster as well. And what type of movement is it? It's away from school. And this was towards school, back to school. And what do you think is happening at the end here? So maybe they're going faster because they got to ride home, and maybe now they're at home. We don't know this. We're not told this, but I think that's a great, like if you were required to tell a story, this is maybe what your story would be. Went to Dairy Queen at lunch, stayed there for a little while eating lunch, realized they were late, so ran back to school, spent the afternoon at school. Now, why the lunchtime is way longer than their afternoon, I don't know. But then they went home and got a ride home or took the bus home, I don't know. Then they went home and they stayed at home for the rest of the day. And the graph cuts off, right? So that would be like a detailed description talking about how it's faster here, slower here, mentioning that it's not moving here, those types of things. What do you think? Sound good? Yes? Yeah. Yes, yeah, that's right. Really late, yeah. And then maybe was only at school for a bit because he got suspended and got sent home. I don't know. Yeah. Okay, they shot him out of a cannon to go home. Graph and story match. Match the story with the correct graph. I'm going to give you a minute to work through this on your own and think about it. And then we'll take it up together. So you got to read through some of the stories, look for the different hints. Notice, read the descriptions. So distance from home versus time. What did I tell you about time? Time always goes across the bottom. So don't get that backwards. And distance is the other way. A lot of people, matched story one to something. Can somebody tell me what they matched it to and why? Take it. Why?
it says he left home and he ran to Hortons.
Okay.
Steep, and then he stayed there for a while. They walked back.
Nice. So take a look at graph B. It's steeper here than it is here. So that matches running versus walking. And then he stayed at Tim Hortons for a while. There's something else about this, though, that confirms it for me because this graph looks similar. Graph A looks similar. So Donovan, what do you want to add to that?
On B, he leaves home and then goes back home.
Good. It starts at 0, which is like what you said. It starts at home, starts at 0. Look, this one starts at 0, and he left home. And then I walked home. So see how that one starts at home, ends at home. So B looks good. And then I'm going to cross off B because we're kind of done with B, right? Or maybe I'll just cross this part off to remind me that I'm done. Good. So I'm going to give you another minute if you want to change any of your answers or think about it a bit further. I know some people weren't quite done. Those are a couple of things that you could look for that give you tips on what the answers might be. Okay, how about story 2? Somebody help me out with story 2. Jamali. C. Why'd you pick C? Okay, so I'm going to look at all 4 graphs. Where does A start? Not quite at home. B's already done. Where does D start? Not at home. So it looks like C is the only one left after that first phrase. We kind of know, oh, it must be C. If you're thinking that way, there's different ways of thinking about these, right? I'm looking at the wrong story. I left home, and let's check and make sure the rest of it's right, because we can check that B was right and that kind of thing, and walked to my friend's house. He lives on the way to school. So I walked to my friend's house. He lives on the way to school. Had to wait for a while because he was not busy doing his hair. Because we were going to be late, we ran to school. So I waited, no movement is changing, and then it's steeper, ran, and didn't end up at home, ended somewhere else, like at school. So that looks good to me. Nice. Story 3. What do you think story 3 is? Walker, what'd you have for story 3? D. Why'd you pick D? Do you remember? Ah. So he walked, and then they gave me a ride. What would that be like, a ride? What would that tell us about how the graph should look? And it's going to maybe be really steeper because driving's a lot faster. And then I walked again, and I walked home, so it should end at home. So we go to, what did we say, D? So we go to D, started away from home, slowly, quickly, slowly, ended at home. Nice, I think I agree with that one. And so that leaves A for the last one. I was at school and I ran to Dairy Queen. So I'm at school, which is not home because this is distance from home. And I ran, so this is steep to Dairy Queen. Because it was raining. I stayed there with my friends for a while and then walked the other direction back home. So that's why I went up, stayed here, and then went back and ended at home again. Nice. Very good. Any questions about any of that? See what this story graph stuff is like? Sometimes it gives you it gave us the story and the graph and we had to match them. Thinking about where it started. Thinking about distance from home. So where's home on the graph? For each one of these, home was there in the corner. We had to think about speeds a lot. Where it started, where it ended, those kinds of little tips. Okay, let's look at the next one. The graph represents Andrew's walk with his dog. But all it tells us, and it tells us that this is time in minutes. So it gives us a bit of a scale here, but no scale up here, so I don't know what this is. It's probably 100 meters or 200 meters or 500 meters or something like that. Like how far could you go in 4 minutes? Right? You could think about it like that, but you don't need to guess. If there's no scale, you don't make one up. Okay? It means you don't need one to answer the questions. Where are Andrew and his dog at the start of the trip? I want you to think about this for yourself. How would you determine that? Okay, what do you think, Savannah? Start at home, because look, they're at home because the distance to home is 0. So if this says home here, and the line's there, what if the graph started up here? Then they're not at home, right? Because this is still always the start, because that's where time is 0. And that's where we start our stories. Okay, so at home. Very good. The first place they stop is the park. Andrew's dog was very thirsty and drank from the river for a while. When did they get to the park? Looking at the graph, how could you tell the first place they stopped was at the park? What do you think? Who's going to answer this one? When did they get to the park? Sam?
At 4 minutes.
Why would you say that?
Because it stops going up. It stops getting further away from home.
Yeah, very good. That's where they stop moving for a little while. So that, presumably the dog is drinking there. So when did they get to the park? After 4 minutes. When the dog was finished taking a drink, he saw a squirrel and chased it, moving away from the park. For how long did the dog and Andrew chase the squirrel? What do you think is happening there? Justin, what do you think? Why do you say 3? Five to 7 is how many minutes? 2 minutes. Thank you. Very good. So we want to look at, but some people might have gone from 4 to 7. So just be careful. That's maybe what, but there was the minute that the dog was drinking. So he stops drinking at 5 minutes. And this is obviously the part where he's chasing the squirrel. So for 2 minutes. So for how long did he chase the squirrel? 2 minutes. Good. After chasing the squirrel, Andrew met a friend, stopped to chat for a while. When did Andrew meet his friend? Noah? Yeah, at the 7-minute mark, he met his friend when he stopped chasing the squirrel. So it's at 7 minutes. How long did they chat? What do you think? 3 minutes. So that's how long they stood still chatting there. Very good. I like it. How long did it take Andrew and his dog to get home after they left Andrew's friend? Somebody else? Savannah? Took him 4 minutes to get home, so started walking home at 10 minutes, got home, wait, what's that? This is 14 here. I know it's hard to see. 15, good. So it would be 5 minutes, very nice. So just make sure you read these scales carefully because you can just pick the wrong number off of it, right? What was the total length of the trip? Marley, how'd you get that? So this is where we're looking for the entire from start to finish. And it was 15 minutes to get all the way to the end. Nice. All right, I think we have one more activity here to do together. The following represents Harvey's walk from his home to his friend's house. So very similar to some of the other ones that we've been talking about. In the table below, compare Harvey's distance from home, his speed, and the direction in which he is traveling in the various segments of his walk. So what I want you to do is quickly chat with somebody close to you the kinds of things that you could say, comparing one segment to another before you write anything down. Okay, go. So we're just going to write. We're not going to do anything specific because we don't have a skill, right? So if you're thinking about speed and direction that he's traveling, something like that, how would you compare A, B, and C? Let's pick one and think about the differences. What do you think? So you would say like if you're comparing them, this is slow, this is not, this is fast. Okay, what kinds of things did you come up with? Sam, what did you two talk about?
For A, they're walking.
Okay, so A is more slowly. How do I compare that to B? Justin? So they're not moving at all here, or they're stopped. And then C. Somebody else? Walker? Okay, so and we don't know specifically what happened, but that's an example. Why did you say drove? Because it would be steeper, so it's faster. So this is moving fast. So in one case we were moving slowly, then we were not moving, and we were moving quickly. What else could you say about them? And what does up mean? Very good. So the direction is away from home. They're not moving, so they have no direction. And then what about in the last one? Like you said, the line's still going up, so they're still going away from home. In this case, I don't think we had to come up with a reason why this happened. Jacob said maybe he was walking, got to his friend's house, they hung out there for a little bit, and then they together went and ran somewhere, right? So that's why they're moving more quickly, or they went for a ride. Maybe their parents gave them a ride or they drove themselves, if they're old enough, to the mall to go see a movie or something like that. Like there's lots of ways that you could describe what is happening. We didn't have to. It just wanted us to compare the different segments slowly, not moving, more quickly. Any questions about any of that?